Welcome back, guys. So in this section, before we jump in, let me recap. So whatever we have seen so far, right? So just to summarize so far, what we have seen in the earlier sections is that we have created a disposable Selenium grid infrastructure, and then we took our automation script, the whole thing, everything. We packaged it. We made a build using Maven, and we packaged it. Um, using Maven, and then we basically containerize that. Like we basically created a Docker file, and then we are able to publish a Docker image. Uh, uh, the whole our test scripts, test suite, everything, right? So we are able to package it and publish it like into a into a Docker image, right? So this is what we have done so far. So what is the next step uh, that we need to do here? That is what we just explained before, is that now we have to create a container like what you see here, right? So you will have to create a container out of that automation test script setup, and then you will have to execute just like how you use your Chrome, Firefox containers, Selenium hub. Everything is containerized here, right? So similarly our application or our automation test suite is also containerized, and then once it is containerized, we can go on creating multiple containers and run different test suites using that container, right? So like for example, here we see Selenium. These are the published contain images which we have pulled in and created containers, and this is what we have to kind of pull and create the using the image, Docker image that we just created in the previous section. We have to create a container which basically has Java, and on top of it it has all the things of our test automation scripts and the test automation code and all the dependencies, right? So wrapped up into a Docker image. So we have to create a container out of it. Okay. So now how do we run tests at scale, and how do we multiply this thing, right? So at a given point of time, for example, if I am running the automation script, I am alone running a module, right? So if I take this whole setup and structure, and then I run another I mean, I can ask my colleague to run another module, right? So I can similarly ask another colleague, third colleague, to kind of run module 3, so on and so forth, right? So how do I do that in real time without involving people, right? If we involve 3 people, then it would be a cost. So without involving people, how I can do it? So I can do the it's possible. What I can do is I can take my automation script, I can make a build, I can package it, create a container from the Docker image, and then I can just parameterize this module. Okay. So which module I want to run, as we saw in the Docker file just before, right? So we actually parameterize the module name, and we also parameterize the browser and the hub, right? So let us forget about browser and hub for a moment, but definitely, the module is a parameter. So by using this module, or to give different, to point it to different test suites, I can go on creating, I can go on creating multiple containers and execute different modules of test cases at scale. So that's cool, right? So this is what conceptually it would look like. Okay, so this is a structure of how do I do it is basically we'll see in a moment. The YAML file, the docker compose.yaml file through which you do this. Okay, but bringing back to the same concept of this, what we are going to implement in this file is, right now I have 2 modules, right? In reality, or in an enterprise world, I can have not just 2 test suites. I may have 10 test suites, okay, which I need to run for a release, right? So in that case, I will spin up, I'll use the same structure, and then I'll spin up 10 containers using that image in seconds, right? And then I'll just point each of these container to run a specific module of my or specific test suite in parallel, right? And I can scale the Chrome and Firefox browser as well, that we have seen that how much ever I need, I can go and scale this, and I can and it will all be executed in parallel. So if I have been asked to run 10,000 tests for this release within and the release is tomorrow, right? It is still possible. It is still possible using this scalable Selenium grid infrastructure, scalable, container based automation infrastructure that we see here, right? Conceptually, you get the point. So now another thing is that, I can run all the tests, right? But there could be some failures. There could be some, I need to look at the test results, right, before I sign off. So I need to do volume mapping. That's another thing. When I run all in containers, somebody asked me like, okay, you will execute all the tests in containers, but what about my output results? Will it be all gone once the containers are trashed? No, it will not be gone. So I can do a volume mapping between the container and the local, Linux host, and all the test results will be saved in an output file that is generated from the output folder that is generated by testng in this case. In if you use some other allo reports or report io, report portal.io or whatever, so similarly, it will create another folder and all that is archived. And if you want to upload it to a test management tool like ALM or Jira or what not, right? So all that is possible. Okay, so whatever you have written the code in your automation scripts is still going to get executed in to the container, and then it give back the same results. Okay, and after the test we can trash the whole infrastructure, so that there is no overhead, either if it is used in cloud or it's used on premise or any PaaS environment whatsoever, right? So we'll see all that in action. But conceptually, you have this picture in mind that the docker compose.yaml file that we are going to create, okay, is going to create this structure. Okay, so this is the structure we are going to keep in mind while creating the while writing the code in this YAML file. Okay, so the this is going to spin up into multiple, this is going to scale up into multiple, right? And then this structure and the port mapping, everything remains the same. Yeah. So now let me go to the Docker Compose. I have explained the structure of the Docker Compose.yaml file. So let me explain the code in this Docker Compose.yaml file line by line. Okay. So this is version 3, and then everything is a service here, right? So my hub is a service. This is nothing new to you. So this part of the Docker Compose.yaml file was already there when we created the Selenium grid structure. So it's basically a repetition, right? I'll skip it. So what we do is we bring up the, to quickly summarize, we bring up the hub using the image, you map the port so that you can access it from outside, and then say Chrome, which depends on hub, and then hub under, and then Firefox. So here with Firefox, there was a small, issue or bug within the Firefox thing. Due to that, there was an error. So what was happening was within the container, this Firefox application, it expects higher space. Okay, this is shared memory size, SHM underscore size is basically shared memory size. So usually 64 MB is what is generally allocated in Chrome and other browsers. Everything works fine, most of the applications work fine, but for Firefox there was some issue, a issue in their gate which said that it needs 1 GB, and due to that it was giving some error. So due to that, I just you can just take it as a blueprint that you just increase the size to something greater than 64 MB. Like you can put it as 128, 512, 256 MB, so whatever, right? So I have put it as 1 GB to be on the safer side. Okay, so then until here it is, this structure is a repetition. So now we have to pay attention here, right? So here I am actually spinning my modules, right? So my pet homepage is a one module or one test suite, and then pet search page is another test suite. So here I am spinning each of these. What I'm telling in this Docker Compose file is that each of these test suite will become a container. Okay, so from which image, Docker image, I am going to spin up this container. So I'm going to take my Docker image, right? So Aditya KS slash Selenium Docker. This is my automation test script, what I have actually containerized, right? So I'm going to take my image and then create a container which depends on Chrome and Firefox. Why it depends on Chrome and Firefox? Because I don't want to bring up this container until Chrome and Firefox are up and running, right? So this is the dependency I want to create in the Docker YAML. So that's why it is, then only I can run the test. And then these are the three standard environment variables we saw, right? So I can say browser I want to run in Chrome or I want to run in Firefox. I can specify that. And hub underscore for host points to the hub here, right? I can even specify an IP if I know an IP or a different player, hub IP I need to specify. I can go ahead and give it, but this is the DNS name I am providing here from above. Okay. And then the module, right? So for pet homepage, I pointed to the pet homepage module.xml. Okay. So, and then this is very important, right? So what do I do here is that I do a volume mapping, as I explained conceptually before. So why do I do the volume mapping? I do the volume mapping because whenever my test results or my test gets executed, okay, test ng will write a test output folder, okay, after the test execution. So this test output folder will be created, and all the test result files, HTML reports, everything will be saved in this folder. So this folder is inside the container. So when I say Docker compose down, all my container is gone and all this is gone. So but I need my test results, right? I need to see, I need to analyze that, right? So what do I do here, to do that is the volume mapping. Okay. So what I say here is wherever wherever the Docker compose YAML file is there and I'm executing this Docker compose this file, okay, in that directory I can point it to any directory actually, but here I'm just saying, for simplicity in the demo, in that current directory create spet homepage test results, right? Spring Pet Clinic homepage test results. So create a directory with that name, with the module name, and then copy all the files, test result files inside this. Right? If I say output, then this will also be output, and if I execute another module, that also will be output. Right? So to keep that discretion, so I'm giving the module name underscore test results as a output folder, and it will copy this test output into that. Similarly, the next module is exactly the replica of this, just the module name is changed from instead of home page it's a search page here, and then it will execute the search page. Okay. And then it will create a folder in search page test results, and it will put all the test results into this. Okay. So this is what actually conceptually or logically I'm explaining. This is human readable YAML code. It's supposed to be the most modern and compared to XML, JSON, and all that, right? So it's a very modern format, but we have to be very careful, with all these spaces and all that. Otherwise, it will give you a lot of problems. So this is what I have written in this Docker Compose file. So what I will do now is that I will use again WinSCP to basically, port this Docker Compose file. I'll not show you it again in the interest of time, to this test runs folder here. Okay. So here within the Linux directory, I have created a folder called test runs, so that within this test runs folder I keep the Docker compose file, and then I execute, and then every all the test results, everything gets saved within this test results test runs folder. Okay. So now let us say, let me see the the Docker compose file that's out here. Yeah. So it's the same Docker compose file that that yeah, that we just saw. Okay. So this is the same file that I have copied here in Linux. Okay. Line by line. Okay. So now, right now, I'm in this directory, and let me say, uh, yeah, Docker compose ps. Okay. So nothing is running, right? So when I say now Docker, just when I execute one line of code, right, saying Docker compose up, and then I give -d just to run it in the background. Okay, so that I need the session and the terminal. And so if I run that command, what happens? The code which I have written here gets executed in the Docker compose YAML file. So as part of that, it will spin up this Selenium. It will spin up all the grid infrastructure at runtime, and within seconds these tests will start running, and then the results will be saved into the output directory. Okay, so we'll see it in action now. So right now nothing is running, so I'll say docker compose up and then -d, just to run it in the background. See, I mean, if you run it in the front end, you will see all those logs that we see during the, when we run it from IntelliJ. But I don't want to see all that. So just to keep it like clean, so I'm saying create. See, I can run creating the hub, Chrome, Firefox, and running these two five create containers are created and run. Okay. So let me say docker compose ps to see what's happening now. See, the test runs Chrome, Firefox, Hub. See this, the Selenium grid infrastructure which is brought up, right? So it will not be brought down. Okay, it will be there for unless you bring it down manually. It will be up and running. Okay. However, your test execution, right? So it already executed the test and exited the container. Okay, that's why you see exit status 0. Okay, so that's what you saw that. So now if the test is all executed, then I should be able to see the test results now, right? So let me see. Yeah, so I see these two directories here. This is exactly the map volume mapping whatever I have done, right? Yes, pet home page test results as well as pet search page test results. So these are the two directories where inside that there are a lot of files. So instead of seeing it in Linux, so let me see it here. It will be more easily comprehensible from WinSCP. Okay, so here I have the same directory, and then I will just refresh this. Okay, so if I go here and further refresh, I can see that these directories are just created now, right? So just now. So I mean, I had run a couple of times before, so it has updated the results. Okay, so if you run it for first time, it will run create. So now let me see. This is home page test results, right? So let me open this this thing, this emailable report. Okay, so this is what I see. The home page test results one and the time that it took, and then it passed, right? So I mean, I can go and I can look at more details of results and all that. So but this is basically the test ng report. It's not very it's not that great. I mean, you may have much more the pie chart and all that kind of reports with extent reports or LO reports or so far. But to keep it simple for the demo, I have just used the test ng report. Okay, so similarly, let us see if we can see the other result of the one more test run that happened, right? So my test results are all available. Okay, so nothing is gone, even the container has exited, but my test results are all saved. I can take a look later, right? So let me go to test search results page and then refresh. Okay, and then let me open this emailable report. Um, yeah, so the find owners test and the launch spring test, right? So both have got executed, and this is within this milliseconds, and both have passed. So both the test cases have passed. So that's about and that's how that's cool, so cool that you are able to basically run the test just by running one command saying docker compose up, and then you are able to get the results. And this docker compose YAML file is you understand now the structure of this file, right? So you can go on creating multiple modules, and whatever browsers you want to repeat the test, you can everything is highly configurable. And you can go on updating this compose file. You can create multiple compose files and multiple things, and then you can just execute the tests at scale. Okay, everything happens in containers, and you get the results output directory, and then everything is thrashed. So this is a highly scalable next gen test automation model that we are seeing here, where it is, coming multiple steps ahead of, earlier we saw that automation, and then now we see that, packaging, CI/CD, continuous testing, and now containerized continuous testing, and a disposable infrastructure, right? So this is cool. So hopefully you're able to follow until now. So now I will, this kind of completes, the test execution part of it. But before I jump on to the next thing, so I kind of told you that, I'm going to explain you about the health check thing, that I did not explain before. Okay, so let me take, this is kind of an optional thing again. Okay, it's not to, worry too much, but still, I will explain this thing, there is an engineering aspect there that has been implemented, so I'll explain that. Okay, it's not to leave it. Okay. So what happens here if I don't have the health check is basically, okay, so when I bring up this whole infrastructure, even though I say, the hub is dependent on, sorry, Chrome and Firefox are dependent on hub, and then the test is dependent on Chrome and Firefox, right? So that's what I say. So, but what happens is, as soon as the compose file gets executed practically, okay, so this more test script just try to get executed as in when the Chrome is up. Okay, but it will fail. It will fail for initial maybe, 30 seconds or so, or I mean even less. Okay, so it may be couple of seconds also, depending on your environment. Okay, why it fails is, whenever the Chrome and Firefox instances come up, right? So they basically, there is a step that they have to, the first the hub comes up, and then the Chrome and Firefox comes up. So once Chrome and Firefox instances come up, there is a thing that you can see this arrow, right? So both of these containers or both of these hosts have to go and register with the hub. Okay, hey, I am here. I can execute the test on Chrome browser. Okay, hey, I am here on the Firefox, right? So if there are multiple, then all happens at parallel, right? But still there is a small delay of 5, 10 to 20 seconds, okay, or maybe quite less also, okay. So during which time this test script, doesn't understand that and goes to try to execute, and then it will fail for that moment. And once it is up and running, and it will start running, as usual, it will not fail, okay. But if the initial, one or two or three test cases, whatever you are trying to run, it will fail until this Chrome and Firefox is accessible and available. Okay, the hub has to say, register, and then, it will start sending traffic to these nodes. Okay, these containers in this case. Okay, so to solve this problem, okay, there are different ways you can solve the problem. Okay, you can just execute, sorry, there are different ways you can solve this problem. Okay, so you can actually, just execute a shell script where you are saying, sleep for, couple of 20 seconds, right? If you know that, always after 20 seconds your test script is going to be up, sorry, your infrastructure is going to be, everything is going to be fine, and you can run the test, then you can just hard code that also. Okay, it's a simple solution. But what I have done here is basically a bit of engineered solution here. Okay, so let me explain this concept. Okay, again, this is optional, and if you're interested, you can you go through this, or you can skip also. Okay, so what I am doing here is I curl to this Selenium hub. Okay, so let me go to this thing here, this URL. Okay, so let me explain. Okay, yep. See, this URL and this, yeah, it's the same URL, right? So I'm trying to curl to this URL. Okay, so I'm saying, access this IP of the my EC2 instance, and then get to 4444 port, and then your WD hub status, right? So when I execute this, I get this JSON. Okay, so let us review this JSON. Okay, what does this JSON, okay, this REST endpoint, okay, of status gives here? So we can see that, value, and then ready and true. Okay, so let us just focus on this. So when it is giving value ready equal to true, okay, when the status is true, that means, the node is able to accept the traffic, and it's able to send it to Chrome and Firefox browsers and execute the test. Okay, initially it will be false for a couple of seconds, that what I was saying, right? So it will be false, and then it becomes true. Right now, the grid is up and running, so that's the reason. Yeah, grid is up, so it is status is true. Okay, so what I'm doing in this health check script is basically, I'm curling into this, and then this is jQuery. Okay, so this jQuery, what does it do is I'm parsing and reading that value. Okay, the JSON, it is helpful, command line utility to basically parse this JSON and then read it and then get to value dot ready, right? And if that is equal to true, okay, if that is not equal to true, then I write a loop here to sleep for 1 second, and then I keep doing that, keep checking every second, and when it is up, I'll get to this starting point of executing the test case. Okay, so this is what this health check script is, and I point my Docker file, the entry point, to this health check script. Okay, and in turn this health check script will point to my actual endpoint. So that's the reason you could see those lines of code. Okay, and here also you can see within the Docker file that by default in the container image I have only Java, right? I don't have curl installed, I don't have JQ installed, so I need to add all these, just for the sake of running this health check script. Otherwise it will not be able to run. Okay, so that's about this the health check script part of it. Okay, hopefully that's also ironed out and clear now. Okay, so this brings me to the kind of end of this part of the demo. Okay, so let us recap what we have seen in this demo, and also what we are going to expect or see in the next part, right? So now, so far, okay, I have built an automation test suite, I have packaged it, I have containerized it, okay, into a Docker file, into a Docker image, and created containers out of it. We're able to run it at scale, everything, right? So what is left now? So what is left is, on a daily basis, okay, in my project, right, I need to do two things, right? So my automation scripts keep updated, right? So I keep updating. So whenever there is an application change, whenever there is a functional change, whenever there is a data change, or whenever there is a release, something changes to the structure. So whenever that changes, I need to repeat these steps, right? I need to again, compile the thing, I need to package it, I need to create a Docker image out of it, and then I have to publish, I have to pull a container out of it, right? So this is my application deployment, or application build and deployment deployment task of my automation script, right, which is like a Java application now, is an ongoing thing that I need to do this on an ongoing basis, right? Even one line of code changes, I need to repeat this whole structure in order to use it. Secondly, I may my test demands, right, what type of tests I need to run and all that, that also keeps changing, right? So it's basically, if I have to run these two modules, so tomorrow they may say, comment out this module, I don't need this, run some other module, right? So so the docker compose.yaml file needs to be continuously updated to the requirements of the project, and I need to execute these tests, right? So now these are some these jobs what I showed and what I did, just for two test cases, right? So if it is 2000 test cases, then that gets a lot of volume of work which I have to repeat and it will slow me down, right? Unless I automate that part. So that is the step how I can automate that, right? So that is the pinnacle of it, right? So the last part of this stack would be, or last and very important stack of part of the stack is, why don't I use Jenkins to do this, right? So instead of me doing this, right, so I save all this code. Conceptually, I'll explain what we are going to see in the next demo, next part of this demo. Okay, so whatever I'm doing manually here, okay, I want to get it done using Jenkins. Okay, so what I will do is I will save all my automation script into a repository, like a code repository like GitHub. Okay, and then I will create a Jenkins pipeline script, okay, which, and I will write a Jenkins file which will actually pull the code, pull everything. It will create the maven build, it will push the image to the Docker hub, and then it will pull the image, latest image from the Docker hub, and then it will execute everything at scale and get the test results output in the Jenkins output directory. Okay, so basically automating that part as well, so that whenever there is any change, so I just have to commit my code, updated code, and then there are ways that automatically the Jenkins build can be job can be pipeline job can be triggered, right? So it gets triggered, or I run it, scan the repository and run it for the changes, right? Whenever it changes, it will execute and it will run the test for me. It will bring up the container infrastructure, it will bring down and everything, right? So automated through Jenkins. So that would be the enterprise CI CD test automation demo. Okay, and this is the same type of structure that your developers would also use in order to containerize this application, right? So for example, let us say all the developers are developing Java Spring Boot microservices, right, or Java Spring Boot applications, or any Java application. Okay, or it could be a different one also, just that the packaging method would change, but the fundamental component, fundamental philosophy and the structure and the concept still remains the same, if it is a Python program or if it is a Node.js whatsoever, right? So they also do the same thing on a daily basis, right? So they also update the application code, deploy it, and then containerize it and deploy it into, like, a PaaS environment like Azure or OpenShift, Red Hat OpenShift, or it could be AWS or whatsoever, right? So, or it could be on premise as well, right? So um, so we, as a testing team, or as a part of the test members of the team, of this agile team, right? So we also follow the same DevOps setup, and we also do the same thing for our automated test scripts. So that's the fundamental synergy here that we are going to see. And in the next demo we'll see the what how do we take it to the next level to put it into Git and run it to Jenkins, the configuration on Jenkins and action on the Jenkins. Okay, thank you, and hopefully you are able to appreciate so far the containerized orchestration, and you are able to, I mean, that hopefully brings you to the interest to the next part of this demo, and I'll keep you until the end. Okay, thank you very much.